as well as I'm just planning to share my screen. Okay, so you're able to see my screen, right? All of you? கேக்குதா? Okay, right. So what is that we have covered in our previous class? We understood the IP address, the need of an IP address, and what MAC address will be doing it. What is the structure of your IP address? What are the two components of your IP address, like your network ID and host ID? Right, so we have seen the dotted decimal system, how we got the dotted decimal system. We have also seen the first octet rule, with which we will be able to classify A, B, C classes, and we have seen what is the range of class A networks, class B networks, class C networks. Then we understood class D and class E is also there. Like class D was reserved for multicasting, whereas class E is reserved for some research purposes, right? And then we have seen the exceptions, right? So the first octet or the exceptional rule. Because of the exceptional rule, all zeros and all ones had become invalid. So because of that, in class A, instead of 0 to 127, it has gone to 1 to 126. 0 has been reserved for any. I told you that I'll explain that what is any later. Same way 127 is reserved for loopback. I explained you that. I'll explain you that later as well. The same way, on the host portion, all zeros and all ones are also reserved for some specific purpose. All zeros to get the network ID, whereas all ones is used to get the broadcast ID. And we understood that in class B and class C, still the valid range is 128 to 191 in class B, in class C 192 to 223, right? So that's what we have seen yesterday. And I also gave a couple of works, like to identify the network, which class, first host ID, last host ID, and the broadcast ID. That is what we did yesterday, right? Now let's continue from there. So being a human, so you are seeing that this is class A, and you know that 8 bits are there for the network ID if it is class A, 16 bits are there for the network ID if it is class B. It is class C, we have 24 bits are there for the network ID. Now how the systems could understand? The devices needs to understand the devices should be in a position to differentiate on the given IP address which part is network ID and which part is host ID. I mean to say, how many bits are network ID and how many bits are the host ID. If you can identify one, the rest is others. What I mean to say, if you can identify which are all the bits are network ID bits, then the remaining bits are host ID bits. Same way, if you can identify which are all the bits are host ID bits, then the rest of the bits are going to be network ID bits. So you have two sides of a coin, right? கொஞ்சம் மியூட் போட்டுக்கோங்கம்மா, whomever it is, right? You have two coins, right? So if you're swinging your coin, the tossing your coin, either you'll get head or tail, right? So if it is not head, then obviously it is going to be tail. If it is not tail, then obviously it is going to be head. Same way, on an IP address, if you can identify the network ID bits, then the rest of the bits are going to be host ID bits. The same way, if you can identify the host ID bits, then the remaining bits are going to be okay. So now we know, as a human, we understood which bits are network ID bits and which bits are the host ID bits. Now the devices have to understand, to help them to differentiate which bits are network ID bits and which bits are host ID bits. There is a concept called as what? Subnet mask, right? There is a concept called as what? Subnet mask. By having the subnet mask, we are giving the information to the devices that these are all the bits are network ID bits and these are all the bits are host ID bits. How we are going to be doing that? Let's see that. See, the subnet mask is also 32 bits in length, as like your IP address, expressed in binary, right? For our convenience, we are converting that to dotted decimal system. That means what? It is like an IP address. The subnet mask is also looks like an IP address, but the difference is, without IP address, subnet mask has no value to it, right? So subnet mask has 32 bits expressed in binary, expressed in dotted decimal system. Okay. Now, so for our convenience, we are converting that binary values into dotted decimal system. So as like IP address, in subnet mask also you have 4 octets, And those values are going to be converted into decimal, and we have a dot to differentiate each and every octet. So we have a dotted decimal system for subnet mask also. But one thing that you need to understand in subnet mask is, when you are working on the subnet mask, you have to understand that every bit of subnet mask is tightly coupled with the corresponding bit of IP address. What I mean to say, in every bit, if you're planning to work, if you're planning to put 0 or 1, that purely depends on the corresponding bit of IP address. Let's take a case. Now I have 10.1.1.10. This is my IP address. Okay. Now if you convert this one into decimal, we will get the values like what? Okay. We have 32 bits. So 1010 will be the first octet binary value. Let's see that. 0 0. The remaining bits are going to be set to 0. Means I have converted decimal value 10 to binary. Same way, second octet value I have 1. If I convert that into binary, I will get it what? 0 0 0 0 0 0 1. Same way, third octet value is also 1. So the corresponding binary value will be 0 0 0 1. Fourth octet value is 10. So this is going to be 0 0 0 0 1 0 1 0. Hope this is clear. Now I'm planning to work with the subnet mask portion. Now subnet mask is also 32 bits in length. Remember that part. Okay. Now my point is, as I said earlier, every portion, right? So every bit of your subnet mask is tightly bound to the corresponding bit of IP address. If you're working on first bit of subnet mask, you have to look into something. What is that something? I'll tell you. If you're working with the first bit of subnet mask, you have to look into something on the first bit of IP address. When you're working with the second bit of subnet mask, you have to look into something on the IP address, right? The values of subnet mask is purely related to the corresponding bit of IP address, right? Now, one more thing. I wanted to say, like, the first bit of IP address belongs to network ID or host ID. In the given IP address is 10.1.1.10. It is a class A IP address. So obviously the first 8 bits are going to be network ID bits, correct? The first 8 bits are network ID bits. The remaining bits are host ID bits, correct? The remaining 24 bits are host ID bits. Now I'm getting into the subnet mask portion. I'm trying to put 0 or 1 on the first bit. When I'm trying to put 0 or 1, I just need to check the corresponding bit of IP address. If the corresponding bit of the IP address is network ID, then the value will be 1. If the corresponding bit is not belongs to network ID, then it will be 0. Right? Now, if I apply the same logic on my subnet mask portion, the first 8 bits are going to be true bits, remaining 24 bits are going to be false bits. So I put 111 here. Here I have to put 0 because the corresponding bit is not part of network ID. So it is part of, it belongs to the host ID. So the respective value here will be 0. As I said earlier, the subnet mask bits can be zeros or ones. It can be 1 when the corresponding bit is network ID bit. It is going to be 0 if the corresponding bit is a host ID bit. Is that clear? So, what happens basically, I am trying to build something called as a subnet mask. It is 32 bits in length, expressed in binary. For our convenience, we are converting that into 4 equivalent parts and then dotted decimal system as like an IP address. Right? Now, the point is, in each and every bit of subnet mask, you have only possible 2 choices. It can be 1 or it can be 0. When it will be 1? That's the question. So, as I said earlier, every bit of subnet mask is tightly bound with the corresponding bit of your IP address. So, when I'm working on the first bit of subnet mask, I'm checking the status of my IP address bit, the first bit of IP address. So, if the first bit of IP address belongs to network ID, and then the first bit of subnet mask will be set to 1. What I mean to say, when I'm working on the first bit of subnet mask, I'm checking whether the corresponding bit of your IP address belongs to network ID or host ID. If it belongs to network ID, then that bit value will be 1. The corresponding bit belongs to host ID, then the bit value will be 0. After I apply the same logic, because on the given IP address it belongs to class A, the first 8 bits are going to be network ID bits. So, the first 8 bits on the subnet mask will be set to 1. Remaining 24 bits are set to 0. Now, if I convert this into decimal, the first octet value will be 255, the second octet value will be 0, the third octet value will be 0, and the fourth octet value is also 0. So, for class A networks, because all of the class A networks are going to be having 8 bits reserved for the network ID, and hence all of the class A networks will have the subnet mask being configured as 255.0.0.0. When you feed in this value, anyway, the device is going to be converting this dotted decimal system into binary. When it sees the bits as 1, the device can understand the corresponding bit belongs to network ID. So, in this way, the devices can understand and differentiate which are all the bits are network ID bits and which are all the bits are host ID bits. While you are seeing this may be looking like very simple, but actually speaking, when we get into a next topic which is called as a subnetting, this will help us to achieve that. We will see that little later. Okay. Now, for class A, the subnet mask is 255.0.0.0. Let me give you another example. So, I'm just clearing the board. Okay, you can see that. If you want, you can have a note. உங்களுக்குலாம் புரிஞ்சுதாமா அந்த பக்கம் இருக்கிறவங்களுக்கு? Do you understand? Okay, super. Okay, now I'm just going to be giving you a couple of sums over here. Now, what is that? Let's say that 150.160.170.180. This is the IP address given to you, right? The second IP address I'm giving it to you is 210.211.212.213. What I need is, what is the respective subnet mask for these two IP addresses? You just need to find and fill in the value. It would be so simple, right? So, for class B, how many bits are network ID bits? 16 bits. You can easily find it, right? For class C, 24 bits are network ID bits. So, the subnet mask, so we understood 150 belongs to class B. So, 16 bits are there. The subnet mask is going to be 255.255.0.0. Whereas for class C, because this is class C, then the subnet mask for all class C networks will be 255.255.255.0. Hope this is clear. There won't be any questions on this. Okay, now we are getting into a little bit of trouble. What I mean to say, Now, what is a network we understood? A network is nothing but a group, right? Now, what I mean to say, if you have a company, let's say I have a company A, right? Now, I have a company A, there are two departments in that. Department number 1 is HR and department number 2 finance. Just for an example, don't ever expect that to have only HR team and finance team in a company without having an income. What is the point in having HR and finance? Obviously there will be production, obviously there will be some other business teams will also be there. Just for our discussion, I'm taking two departments. One is the HR, the other one is finance. Maybe the company could be finance based company, then because of that they may get money. That's a different story. Something got into my mind. Okay, I have two departments. What I want is, I wanted to segregate the traffic of HR department and finance department. That means I just want to differentiate. This traffic belongs to HR, this traffic belongs to finance. Same way, I wanted to group all of the devices of HR team into one, all of the devices of finance into one. So typical thing what I can do is, I can keep them in, for example, this guy is 10.0.0.0. I have given a network ID for him. So now what happens here? 11.0.0.0. Okay. So HR team we have taken 10.0.0.0 and finance team we have given a different network so that we can segregate the traffic or differentiate the traffic of different departments. But the question is, which class it belongs to? Class A. So we have 2 to the power of 24 number of host IDs minus 2, of course, don't forget that. Same way for finance also, we have 2 to the power of 24 minus 2 number of host IDs, right? Now think that, do you think these many HR people will be there in an organization? Even if you have 10,000 employees who belongs to development, who belongs to production, who belongs to sales, who belongs to marketing, even if you have 10,000 employees, do you think that you need to have these many IP addresses for the HR department? So 10,000 employees, let's assume that we may have some 100 or 200 HR people or HR devices. Just to have 200 IP addresses, we have taken 2 to the power of 24 minus 2 number of IP addresses. How many IP addresses are getting wasted? Think about it. The same logic applies to finance as well. Now we might be having only few devices over there, but still we are taking a class A. Then what happens? We are wasting so many IP addresses. Keep in mind, IP addresses are not free of cost, and you won't get the IP addresses just like that. Even if you're asking for a class A, you may not be able to in a position to receive that one. For every IP address, you have to pay as well, and even after you pay, you cannot own them, you only can lease them, right? So if you need an IP address, you can approach your service provider. The service provider will be taking the IP addresses from the registrars, right? The registrars will be having an IP address allocated to them, right? They will distribute the IP addresses to the countries and service providers. When the customer is approaching the service provider, they will be getting certain things. Okay, this is the logic. But even then, you will not be able to buy or own an IP address. If that is the case, do you think any company will be willing to waste the money involved in wasting the IP addresses? So you have 100 IP, you need only 100 IP addresses, but you are taking 2 to the power of 24 number of IP addresses. Again, a lot of money getting wasted. So they wanted to divide, or they wanted to do something just to safeguard the waste, or just to avoid the wastage of IP addresses. Somehow they wanted to do something. Okay. Now, whatever the networks we have seen, class A, B, C, are called as what? Networks. Okay. Now consider this as your flat. You have around 2000 square feet of flat or house. Would you keep 2000 square feet of sized house as a single room? You will slice it, right? So let's say that I'm just going to be having 1 bedroom or 2 bedrooms, 1 hall and 1 kitchen, probably. So 2000 square feet with the 2 bedroom, the bedroom size is going to be large. That's okay. It's okay for me. But my point is, instead of keeping the whole space as a single room, I'm slicing the flat or the space into smaller rooms according to the usage. Right? So I want 1 bedroom as a larger bedroom and 1 bedroom as a small bedroom and a large hall and a kitchen. This is what I want, right? Even though I slice the house into 4 or 5 rooms, every room is going to be identified as so and so address only. You understand? So that this networks belongs to this subnets or these rooms belongs to one single physical house. You understand? The addresses are going to be the same. So what I mean to say, when I take a network called as what? 10.0.0.0, I call it as a network, right? So I call this as a parent network or major network. Keep in mind, this is a parent. Now what I do is, this is your 2000 square feet house. Now from this 2000 square feet house, I'm going to be slicing or I'm going to be building some rooms. Within that space, I'm just creating some rooms, right? And these rooms are called as subnets, right? Subnets or child networks. So I have major network. I also have subnetworks. Subnetworks are also considered as network IDs with respect to subnet mask. While you are working with subnet mask, keep in mind whether it is a network ID or a subnetwork, then the values will be 1. Parent network or child network, it doesn't matter for me. While I'm working with the subnet mask, if the corresponding bit belongs to net, whether it is a major or sub, it doesn't matter for me. If the corresponding bit belongs to network, then I have to put 1. If not, the value will be 0 on that bit. Okay? Now, so I know that one major network can be sliced into more than 1 or more than 2 or more than 2, more than 5 or more than 10. However you want, you can do it. According to your need, you have to do it. Now let's take the same example. I have 10 network. Okay? 10.0.0.0. Right? Now I want 2 child networks from out of it. I have network number 10. From this, I want to create 2 child. Okay? Now what I do is, out of these 24 bits, I don't have any control on the network bits. Whatever is given to me as a network, that is mine. Right? I cannot do any changes on that network ID portion. But the remaining 24 bits are owned by me. What I mean to say, if you have a flat system, you took only 2000 square feet of one flat, right? You can do whatever you want within that 2000 square feet. You cannot pull some additional space from the other flat. That is not possible at all, right? Unlike your Munnava MBBS or what is that? Na MBBS ada? Vasul Raja MBBS. You cannot say that take this 6 and take this 8 and then 678. That is not possible at all. So whatever the space is given to you, that is what you own, right? Whatever the flat number is given, that is a flat number. So within that flat, whatever the space you own, however you want to slice, you can slice it. Okay? Now I have 10 network, 10.0.0.0. Now I wanted to create 2 networks out of it. So understand that if I need 2 networks, I need to have something to be done on the parent network. On which portion? On host portion, because only there I have control. Network ID, I don't have any control on it. Fine. Now, while we were identifying the number of networks and number of hosts, how we got it? See, for class A, I said 8 bits or 7 bits. I said that 2 to the power of 7 number of networks minus 2. What do you mean by that? 2 to the power of 7. In binary, every combination of network ID, you will get one network. Same way, every combination in host ID portion, you will get one host. You understand? If I have 10 bits, I'll get 2 to the power of 10 number of combinations. So if the 10 bits belongs to network ID, I will get 2 to the power of 10 number of networks. If I have this 2 to the power of the 10 bits on the host ID portion, then I will get 2 to the power of 10 number of host IDs. Clear? Now what I need is, I need to have 2 subnets. That means I need to have 2 combinations at a minimum on the subnet ID portion. You understand? So I have 10 network as a major network given to me. I want to create 2 subnets out of it. How do I create? I will explain you. I already told you that you need 2 combinations on the subnet ID portion. So 10.0.0.0. How many subnets I want? 2 subnets I want. So before I do subnetting, how many portions were there in a given IP address? 2. Network ID, host ID. The moment I introduce the subnetting, you have 3 portions in an IP address. What is that? Network ID, the parent, followed by subnet ID, child, followed by host ID. This is the order. Earlier I had two portions in an IP address. One is called as network ID, the other one is called as a host ID. After doing the subnetting, you will have three portions in it. One is network ID, subnet ID and host ID. This is how it is there. So understand that the network ID portion is a fixed one. I don't have any control on it. The subnet ID portion is the portion you will get the number of bits according to the requirement from the host ID portion. What I mean to say, you are going to be borrowing some bits from the host ID portion and then allocate that bits to the subnet ID portion. How many bits you have to borrow, that purely depends on the number of subnets you want or number of combinations that you are expecting on the subnet ID portion, right? So how many subnets I want? I need to have two subnets. If that is the case, how many bits that I have to take it from the host ID portion and reserve it for the subnet? If I need two combination, I can have a single bit, because 2 to the power of 1 is equivalent to 2. But again, we have to remember that exceptional rule. What that exceptional rule said? All zeros and all ones in every portion of IP address is invalid. You understand? So whatever the calculation you do, 2 to the power of n minus 2 will always be there. Whether it is a network ID or a subnet ID or a host ID, doesn't matter. That minus 2 will always be there. So if I'm going to be reserving only one bit, then what happens? 2 to the power of 1 minus 2 is equal to 0. So you will get only 0 subnets even if you reserve one bit. But if I reserve two bits, now what happens? 2 to the power of 2 minus 2. This is nothing but the number of bits. This is nothing but the combinations which is possible, zeros or 1, and this is nothing but the number of bits which has been reserved, and this is nothing but all zeros and all ones. So which is equivalent to 2 combination in subnet ID portion. So I can get 2 subnets, right? So while you are doing the subnetting in future, don't ever expect that the number of subnets required you can achieve exactly by reserving certain number of bits. So you need 10 subnets, okay? Now how you do that one? My question is, you need 10 subnets. If you reserve 2 bit, you will get only 4. If you reserve 3 bits, you will get 6. 8 minus 2. Sorry, 4 minus, here it will be. If you reserve 2 bits, you will get 2. If you reserve 3 bits, you will get 6. If you reserve 4 bits, you will get 14. If you reserve, sorry, I think correct only. 2 to the power of 2 minus 2, 2. 2 to the power of 3. See, if I reserve 2 bits, this is going to be 2 to the power of 2 minus 2. Two combinations, I'll get it. If I reserve 3 bits, 2 to the power of 3 minus 2, 8 minus 2, 6. If I reserve 4 bits, 2 to the power of 4 minus 2, which is nothing but 16 minus 2, I'll get 14 combinations. But how many subnets I want, means how many combinations I want, is only 10. If I reserve 3, I won't get it. If I reserve 4, I'll get more than what I want. But do you have a choice of saying that I want 3.5 bits to be reserved? That's not possible. When you're reserving, the whole bit needs to be reserved. You can say partially it is subnet, partially it is host. That is not possible at all. While you're reserving, the bit can be part of subnet ID or the bit can be part of host ID. You understand, right? Now let's understand how you're going to be deriving the subnet ID details. Okay? Now the point is, I have 10. So 10 is a network ID. Because of that, I don't have any control on it. Now I'm doing the subnet ID reservation. Let's go for okay. So I have 7 bits. So this is my host ID bits as of now. Now I'm going to be reserving 2 bits from host to the subnet ID. So this is where I'm reserving. 2 bits have been reserved. Okay. Now after I reserve, this is my network ID, this is my subnet ID, and the remaining bits are host ID. Okay. As I said earlier, every combination you will get the respective portion. For example, if you have one combination in host ID, you will get one host ID. If you have 10 combination, you will get 10 host ID. In subnet ID, if you have every combination, for every combination, you will get a subnet, which is nothing but a child, right? So, when I go for the first combination on the subnet ID portion, can I do 0, 0? I cannot go for 0, 0 because 0, 0 is considered as invalid according to the exceptional rule. Of course, we can make use of it. We will see that one in little later. We don't want, the purpose of going for subnetting itself is to avoid the wastage of IP address. Even then, if I'm going to be wasting all zeros and all ones in subnet ID, still I'll waste so many IP addresses. I don't want to do that. So Cisco provides a mechanism to make use of zeroth subnet also. That is not the first subnet, that is considered as zeroth subnet. Okay. Now my question is, what will be the first combination when I have 2 bits? 0, 0 is invalid. So obviously 0, 1 will be the valid combination. Okay. Now as I said earlier, if you keep zeros on the host bits, you will get the network ID. In this case, if you keep zeros on the host IDs, you will get the subnet ID. That's the difference. When you had only network ID and keep all the host ID bits to 0, you got network ID. Because now we have subnet ID, right? Subnet ID, after reserving the host ID portion, host ID bits to the subnet ID, by keeping all of the host ID bits to 0, you will get the subnet ID. Because it is a first combination, you will get first subnet ID. If you go for second combination in subnet ID, then you will get second subnet ID. If you go for third combination, you will get third subnet ID. That's the logic you have to understand. Okay. Now, when I asked for the first host ID, what you guys did, you have gone for first combination on the host ID portion. Same way, when I asked for the last host ID, you have gone for last combination on the host ID portion. That's the logic you need to understand. In this case, I kept 0, 1 on the subnet ID portion as the first combination. If I keep the host ID bits to 0, then I will get the first subnet ID. Let's see that. This is my host ID bits. I'm keeping zeros on all of the bits. Don't worry, this is going to be simple once you understand this. Okay, 0, 0, 0, 0, 0, 0, 0, 0. Now, what I'm doing is first subnet ID. How do you get the first subnet ID? Convert the binary to decimal. I hope you remember, while you are working, you have to work on the specific portion of what asked. Since I asked for subnet ID, I worked on the subnet ID portion. If I asked for a host ID, I would have worked on the host ID portion. Okay. Now the question is, to get the values in decimal, you have to convert the binary to decimal octet by octet. Right. The first octet value already given, which is 10, because that's a network ID. Second octet value, what you have is 8 bits. Convert this to decimal. You have 0, 1, 0, 0, 0, 0, 0. So what is the place value of this bit? 64. So the second octet value is going to be 64. The third octet value, because all the bits are 0, the value will be 0. Fourth octet is also going to be 0. Okay. This is my first subnet. Okay. Now the question is, after reserving the host ID bits into subnet ID bits, we have reserved couple of bits to subnet ID. Now the network ID bits got extended. Earlier we had only 8 bits. Now we have 10 bits. Correct? Now the question is, what would be the subnet mask? Earlier I said subnet mask. That was default subnet mask for class A, B and C. Before doing the subnetting, whatever the subnet mask you have seen, which is called as default subnet mask. What is the purpose of subnet mask? The subnet mask helps the devices to identify the number of bits in network ID and number of bits in host ID. Here, we are not going to be using the default mask because we have additional bits reserved for the network ID portion, right? Though it is subnet ID, it's network ID. Now, we have to call the subnet mask as custom subnet mask. It is not default subnet mask, right? What would be the subnet mask? Tell me. Anyway, it belongs to class A. The first octet is going to be 255. Correct? The all 8 bits are in first octet. All 8 bits belongs to network ID. So you had all 8 bits as 1. So you got 255. In my second octet, I'm trying to put 1 or 0. Of course, third and fourth. Let's see that one, how that comes. Now, I'm trying to work on the first bit of second octet in subnet mask. I'm checking the corresponding bit, the second bit of IP address. Is that host ID? No, it's not host ID. But it's not network ID also. But it is not host ID. So I told you already, whether it is a subnet ID or a network ID, doesn't matter. From subnet mask perspective, you have to keep 1. If it is host ID, then keep it as 0. If not, keep it as 1. Now, if I apply the logic, the first 2 bits are going to be 1. The remaining bits are 0 because third bit of your IP address belongs to host ID. Now, convert this to decimal. 11, all zeros in second octet. What would be the value? 192.0.0. How I got 192? 128 and 64. 128 plus 64 is what? 192. So now what happens? So first subnet ID is 10.64.0.0 and the custom subnet mask is 255.192.0.0. Now I just need to find the range of IP addresses, the first host ID of first subnet ID. Every street you will have the door number starts with 1. Same way, every network, every subnet will have first and last host ID because that is the set of IP addresses. Now tell me how many host IDs you will get it in this subnet. Earlier we had 24 bits on the reserved for the host ID, correct? So we had 24 bits. From that 24 bit, we have reserved 2 bits to the subnet ID. So I will have only 22 bits on the host ID portion, but I will have this 22 bits in all the subnets. This 22 bits available in first subnet, 22 bits available in second subnet also. So number of host IDs per subnet will be 2 to the power of 22 minus 2. In this 2 to the power of 22 number of host IDs, what is the first host ID of first subnet? How do you find the first subnet? Go for the first combination on host ID portion, which is, see here, on host ID portion. How do you find the host ID? In host ID portion, you have to go for all zeros and keep the last bit as 1. If I keep the last bit as 1, now what happens? 10.64.0.1 because I kept zeros on all the bits of host ID but last bit as 1. Now I just need to go for last host ID. All I have to do is reverse the first combination, which is nothing but the last combination. What I have to do, I'm just keeping ones in each and every bit. I'm just keeping ones in last. So this is going to be 1, this is going to be 1, correct? In host ID bits, I just need to go for last combination 1 1 1 1 1 1 1 1 1 1 1 1 1 1, but the last bit is going to be 0, right? This bit is going to be 0, the last bit. Now convert this into decimal. Of course, the first octet value will be 10, but the second octet value got changed now, right? So this is going to be, you add all the values except 128 because 128 bit is false bit. Now if you add that one, you will get 127. The third octet value is going to be 255 and the fourth octet value is going to be 254. Now you know how to find, what to be find now. Broadcast ID. What is the broadcast ID of first subnet? Which is nothing but plus 1 of last host ID, which is 10.127.255.254. Is this clear? Sorry, 255, not 254. It is going to be 255, correct? It's going to be 255. So this is the broadcast ID of first subnet within 10 network if I reserve 2 bits from host to the subnet ID portion. Clear? Now, I'm going to be asking you to find this next subnet. You have only 2 subnets possible, right? According to our explanation, we can have only 2 subnets. What is the second subnet ID? Right? So I'll put it here. The second subnet or the last subnet ID. Then what is the custom subnet mask? Then what will be the first host ID of last subnet? Then what will be the last host ID of last subnet? and what is the broadcast ID of the last subnet. This is what you are going to be finding. Okay. Go for passing as well. Oh, I don't have